What we want to do here is we want to start learning how to apply the properties of definite integrals. So I have written here three rules basically for properties of integrals. So the first one says that the integral from a to b, or the integral from, okay, we'll read it this way. We'll say from a to b of f of x dx plus from b to c of f of x dx is just the entire integral from a to c of f of x dx, which is a nice property to know. We're going to need to use that here for this problem. Then the next property that I have written here is it says that the integral of a sum is the sum of the integrals. That's what you say that. And it just says that from a to b of f of x plus or minus g of x. So the integral of a difference is just the difference of the integrals, is again what this is saying in two things, because I wrote plus or minus. G of x dx is just the integral of f of x plus or minus the integral of g of x dx. And from a to b it has to be obviously, but okay. Now, next thing, last thing that we need to use here is that if I swap the bounds of integration, I'm going from a to b. If I go from b to a, then the integral becomes negative. It flips its sign. It has that negative in front of it. Now, let's use these properties in this problem here. So we're given certain facts, and then they ask us to evaluate. So the first thing that they ask you to evaluate is this integral right here. So let's see what information I have about f of x. Well, I know that from 2 to 5, the integral of f of x dx is 6. Then from 5 to 8, it's 9. So this is as simple as using that first property. This is the integral from 2 to 5 of f of x dx plus the integral from 5 to 8 of f of x dx. And we know what this value is, these two, right? This is like this one where it left off at b, then it picks up at b, so then the integral is just from a to c, right? It left off, it went from a to b, then this one went from b to c, and that's just the integral from a to c. So it went from 2 to 5, then from 5 to 8, and that's just the integral from 2 to 8. And we know this one's 6 plus 9, 5 to 8. And then now I know that this then whole thing is going to be 15. And that's the answer for part A. Now for part B, we need to be a little bit more careful, but we can still do this as well. So let's see what we have now. So the first thing is I want to use that second property. I want to say that this is from 2 to 5 of f of x minus the integral from 2 to 5 of g of x. And I forgot to write dx here. You should never do that. You should always remember g of x dx. And now I want to look at this and I want to say to myself, well, I know the integral from 2 to 5 is 6, so I got that. That's 6. That's all good. I'm all good here. Now let's see what this one is. 2 to 5 of g of x dx. And once I get this, then I'll know my answer. And it tells me that from 5 to 2, g of x dx equals 3. Now that's from 5 to 2. So I use this third property here that says that if I switch the bounds of the integral, where if I put 2 to 5 like this just becomes negative. So I flip the bounds, and it's just the negative of the original. And that means that this, from 2 to 5, right, is equal to negative 3. Am I correct in this? Okay, so once I switch the bounds, right, then this just, so this value here is going to be negative. Yeah, so this is going to be negative whatever the original value is. Why am I having trouble with this now? So let's see. So if I flip the bounds, this is for sure going to be negative 3. But why? How do I illustrate this? So I know that right. Okay, I apologize. Why am I having this problem? So from the integral from 2 to 5 g of x dx, by my rule, right, that's equal to the negative of whatever this one is, from 5 to 2, g of x dx, because I flipped the bounds. Now I know that this one's 3, and then I have the negative here, so I can multiply by the negative, and I get that from 2 to 5, this integral here is negative 3. I'll show you again, just to illustrate my lack of concentration that I had there. 5 to 2, g of x dx, g of x dx, right? Now, that's equal to the negative of from 2 to 5, g of x dx. And I know from this equality here that this left-hand side equals 3. And I don't want the negative of this integral, so this is a negative 1 in the front. So, and a constant you could always factor out, right? And you can move it outside the integral. It's already outside the integral. But basically then, if I multiplied by negative 1 on both sides here, I would just get that the integral from 2 to 5 of g of x dx is indeed negative 3. And then now that helps me solve this one, because now I get 6 minus the negative 3 is just 9. And that's my answer for part B here. Now for part B, now let's look at another one. Here we have to apply our properties of integrals as well. And for removable and jump discontinuities, we would just evaluate the integral normally. We're just going to find the area that we have underneath and in front of these curves, and we'll compute that area, and then we'll be perfectly on our way here. But now let's go through what we have here. So what do we have here? We've got, they want to find the following integrals given the graph of f of x. And it tells you that this is a quarter circle, which is key. And they also tell you that the other two things are line segments. And we want to first do the integral from 0 to 2, which is this integral here. And we don't really worry so much that it's not defined, or it's a jump discontinuity at 2. We just find the area of this pink region, and since it's below the x-axis, it's going to be negative. So what is the area of that pink region? Well, it's a quarter of a circle. The full circle is pi r squared as an area. So then the quarter circle is going to be 1/4 of that value. It's exactly 1/4 of the entire area of that circle. So it's 1/4 pi, and the radius of this circle is 1, 2. 1, 2. So it's 2 squared, which is 4. And then 4 times the 4th is going to give you 1. And then I'm just left with pi as the area. And then I have to remember that the area is beneath the x-axis, so it's negative pi as my first answer. Now, from 3 to 5, we got to be a little careful. We got to just make sure we're nifty with our geometry. I could find the area of this, let's do it in a different color. I could find the area of this green triangle. And then I could find the area of this orange, the big orange triangle. And I could subtract to get the area that remains. So I want the area from 3 to 5, right? I want from 3 to 5 here. So the way it is that I do that is I want from 3 to 5. Let's look at that region. So let's just look and see how I'm approaching this. Make sure we can justify the subtraction of areas that I'm doing here. So I want to find that blue region, right? But I should see that the area of the blue region plus the area of the green region is the area of this entire triangle. And finding the area of this triangle is not so bad, because I can visually see that the height of this triangle is 2. The entire orange triangle, and then that's from 2 to 5, so that's 3. And then this is 2 2 times 3 is 6, and then divided by 2 is 3. So I know that the area of the entire orange piece, the orange triangle, is 3 minus. Now let's find out the area of this little green shaded region, which is also just a triangle. And that goes from 2 to 3, which is 1. And then the height of it is 1. So the area of that piece is 1/2. Because 1 times 1 is 1, divided by 2 is 1/2. And now I have that it's 3 minus 1/2, which is 2.5, which is 5/2. 5/2. And the last part, okay, what you do is you basically now sit here and you wonder, well, I found out the area of the orange triangle was 3, right, in this last piece. And I found out that this area here is -pi. So the integral from 0 to 5, we don't worry again about this jump discontinuity here. The integral is just going to be this part area negative and then added to this part, which is positive. So at the end of the day, that orange triangle was 3. So it's 3 and then minus the pi, because that first integral was -pi. And then that is your answer. And these are your 3 answers for this.